first sign something was wrong did not come from our monitoring. It came from a customer email. "Your dashboard is not loading." At first that sounded like a normal support ticket. But within minutes more messages appeared. Some users said pages took forever to load. Others said buttons did nothing. A few reported the site freezing entirely. So we checked the monitoring dashboards. Everything looked perfectly healthy. CPU usage was normal. Memory looked fine. Error rates were almost zero. From the system perspective, nothing was wrong. Yet customers were clearly experiencing problems, and the support channel kept filling up. Environment context. Our platform ran primarily on AWS. The core application lived inside a Kubernetes cluster running on EKS. Around 140 pods handled authentication, API requests, background jobs, and web rendering. Traffic averaged around 4,000 requests per second. The web front-end was served through a CDN that routed dynamic requests to the cluster. Application services connected to a PostgreSQL database on RDS. Redis handled caching. The deployment pipeline ran through GitHub Actions and Argo CD, pushing container images to the cluster automatically. Monitoring consisted of Prometheus and Grafana dashboards. Datadog tracked request latency and error rates across the API layer. Normally, those signals provided clear indicators whenever something broke, but this time the system looked healthy. Initial symptoms. Users were reporting that certain pages would load halfway and then stop responding. Sometimes the UI froze entirely. Other times, requests took 10 seconds or longer. Yet our metrics told a different story. API error rates remained below 1%. Latency averages were within normal thresholds. The load balancer showed healthy back-end targets. Nothing suggested a major outage. Still, the support team insisted the product was unusable for some customers. The strange part was that the issue seemed inconsistent. Some engineers testing the site saw no problem. Others experienced delays immediately. It depended on where the request originated. That inconsistency made the investigation difficult. Investigation and escalation. The first hypothesis was network latency between regions. Perhaps a routing issue was affecting specific geographic locations. We checked CDN metrics and edge node performance. Everything looked normal. Next, we suspected a database bottleneck. Long-running queries could cause UI delays without necessarily generating errors. But database performance dashboards showed stable response times. Then someone noticed something unusual in the browser developer tools. Requests were technically succeeding, but several responses contained incomplete payloads. Large JSON responses appeared truncated. That should not happen unless the connection closed prematurely. We examined the API logs. The requests completed successfully. But the response sizes were suspiciously consistent. Exactly 1 megabyte. Every truncated response ended at almost the same size. That pattern suggested something was limiting response payloads. Root cause. The root cause was an unexpected configuration change in the CDN. Earlier that week, a security rule had been deployed to limit response sizes in order to protect against large payload attacks. The rule capped responses at 1 megabyte. Unfortunately, the API endpoint for the dashboard returned large JSON objects. Many legitimate responses exceeded that size. When those responses passed through the CDN, the edge node truncated the payload silently. From the API perspective, the request completed. No error was returned, but the client received incomplete data, status code 200. Because the HTTP response code remained 200, monitoring systems recorded the request as successful. That is why every metric looked healthy. Mitigation and recovery. The fastest mitigation was disabling the CDN rule that limited response sizes. We removed the rule and redeployed. Within minutes, new responses began flowing through without truncation. Engineers tested the dashboard again. All payloads arrived intact. Page rendering returned to normal. The support team confirmed customers could load dashboards again. Total time to recovery, 40 minutes. Post-mortem reflection. What actually failed was the gap between infrastructure monitoring and user experience. Our metrics focused on status codes, but they did not verify that response bodies were complete. The CDN rule introduced a subtle failure mode where requests technically succeeded. Because error rates remained low, automated alerting never triggered. The only reliable signal came from user reports. The security rule had been deployed with good intentions, but the change was applied at the edge without understanding its impact. Engineering lessons. Monitoring should include synthetic tests that validate full behavior. Response integrity is as important as status codes. Edge layer configuration changes can introduce subtle application failures that backend systems cannot detect. API responses should be monitored. Most importantly, observability should reflect the user experience rather than only the internal state of the system. That afternoon was a reminder. A system can look perfectly healthy on every dashboard while quietly failing the people who actually use it.